He's a professor and director of data analytics at Azusa Pacific University. He's going to share with us the dynamic data visualization for pattern seeking and insight discovery. Let's welcome Alex.
Okay, testing. So, can you guys hear my voice? Okay, great. Okay, so my topic is about visualization. You may say, oh, common sense, right? Yeah, we see report, we see pie chart, histogram, bar chart, and so on. Well, okay, what is new? What is special about this topic? Well, the keyword is the first one, dynamic. Okay, so what does it mean? Well, yes, it's common sense. You know, every textbook, every introductory course in STEM, in analysis, all the report you can see on the web show you some graph. Okay. However, it's important when we want to perform data mining. The goal is pattern seeking. So, which means the traditional status, non-dynamic, frozen system will not work. Here, you know, is an output from a system. I will not name which one. I don't want to offend, you know, people. So, well, the output is a regular time series graph, you know, with up and down and so on. The problem is you cannot drill down. You cannot uncover additional detail. The graph is frozen, so you cannot add something new. What if I do that? What if I remove something? What you see is what you get. Period. Okay, that's all. Okay. So some system allow you to change the appearance, the look and feel. Oh, I want to change the color. Okay, I like purple, I like blue, I like green, or resize it, or add like or change the title, and so on. Well, changing title, changing the legend, and so on, may enhance some look and feel. However, it's not the core, you know, the major features for you to uncover insight, to get additional information from the data. So I don't call this kind of system fully interactive. Okay, what you see is a screen capture from a major software app. I will not name which one. Okay, how about a semi dynamic system? By semi, okay, I mean this is a one-way street, which means the user can manipulate the output from the input channel, like you know the drag and drop box, point and click, and so on. Why is important? Well, it's crucial. In traditional analysis, usually it's a single shot. Well, we have all the, so we have predetermined research problem. We have preconceived idea. We have preconceived hypothesis to test. Also, you know, we have predetermined theoretical sampling distribution. Oh, this is a Poisson, this is the binomial, this is normal, and so on. We know everything, or you pretend you know everything, and then you test it, and then you know you just input everything, push a button, run the model, and so on. However, in my opinion, modern analysis should be something like contextual, which means like travel. You know, oh, I set my plan. Oh, Monday, Grand Canyon, Tuesday, Sedona, Wednesday, Kansas City, and so on. But what if bad weather? Yeah. But what if, you know, a traffic jam? poor road conditions and so on. So you want to, make your subsequent plan should be based upon the condition, the context, right? The same idea. When you perform analysis, then you don't want to just do everything at once. Rather, you want to make it contextual. You want to make your subsequent step based upon what you see in one step. So what if they are outliers? What if they are non-linear patterns? What if you have poor data and so on? So in a semi-system, the output can be changed by the input. You can click, click, click. You can add, remove, and so on. So the subsequent output will based upon what you see at some moment. So like travel, like exploration. Okay. However, I call this semi, because you can change the output from the input, but when you click on the output, the panel, the graph, and so on, nothing changed. So a fully dynamic visualization system should be something like everything, the data table, input, process, output, and so on, everything are interlinked. In this configuration, manipulating anything, any feature, any variable, any observation in any object can trigger changes in all other objects. For example, you can do this in SAS Wire, SAS Visual Statistics, SAS Visual Analytics, Joomla, Tableau, also RGL in R. RGL is some kind of something like OpenGL. So why do we need dynamic visualization? The key is pattern recognition, pattern seeking. The traditional approach, as mentioned before, right? You have everything predetermined. You know the model, you know the distribution, and so on. And usually the decision base is a cutoff. P-value 0.05, Banner index 0.8, and so on. So the decision outcome is either yes or no. And also the evidence is crucial. It's also yes or no. However, when you want to do data mining, then you want to look for a pattern rather than you count on some score, some cutoff, and so on. When you want to do a pattern recognition, the overall pattern, rather than just yes or no, true or false, then you need interactive, iterative process, not a single shot. So go back and forth between model and data, and so on. A system allows you to visualize, to perform dynamic visualization. Will let you ask what-if question. For example, how will the regression slope change if I remove one or three or more extreme cases? Will the association between X and Y remain the same if I insert another moderator, mediator, and so on? Well, in the past, you could do that, but you have to rerun the model. But now, a good system should allow you to do it on the fly, in real time. You see right away, rather than, you go back and we do all input, and then you mentally connect, this is model A, model B, and so on. So, there are some basic, there are some simple ideas I found that, people rarely use it. People may show like, oh yeah, a bar graph, a histogram, a box plot, and so on. But it's rare for people to concurrently, simultaneously, superimpose 2 or 3 or 4 graphs together. Why do I do that? Well, here, what you see is superimposition. I superimpose the Wiley plot and also the box plot on the raw points. Okay. There are 3 pieces in one. Essentially, visualization is moving back and forth between noisy displays and smooth presentation. Noisy means you show more details. Okay. But then you take the risk of overplotting, too much information. Smooth is that you suppress the data to a function, to a model. But the risk is that you sacrifice some detail, then you may be misled, and so on. But how about we use both? When you use a 5-point summary, a box plot, then you have contour information. This is a smooth presentation. You suppress information. But also, when you show the raw data as dot, then this is noisy. However, when you have distribution in the Wiley plot, then this is something in between. Why not, doing superimposition? Okay. So you get a holistic view. You get the contour information, the distribution, and also expose outliers. Okay. Here is overplotting. Today this is common. When you work for big corporation, chances are every single day you receive 100,000 million cases. Okay. Traditional visualization, like this one, scatter plot, well, will show you a dark cloud, a large block of ink. Okay. Well, there is a positive trend, but you have no idea about where are the concentrations, where are the majority of the observation, and so on. So over reporting. However, when you have a dynamic system, you are allowed to change the graph type on the fly. You can just, do a one click or, and one switch, change the, the ugly PC dark cloud into something like a heat map, image map. Now, essentially you are doing binning. You just, on the fly, the system classify, partition the data by bins, and then assign color. Red is high, blue is low, gray is something in between, high and low. Then you can see, the observation concentrate at the center, and so on. And also by only using one click in a, then you can change the displays from image map to non-parametric density. Okay. By doing that, you are no longer model-driven. You are no longer, testing predetermined theory hypothesis. Rather, non-parametric means no model, no assumption. You follow the data. You let the data speak for themselves. Now you know that well. So now by the contour, you can tell the detail, the data structure, the data pattern, and this is very straightforward. You don't need any function so on. Okay, but you can't do that when you have a frozen system. Okay, here is another typical graph you may see in any textbook, a radar graph, also known as a spider graph. When you have, let's say, 4 or 5 features, when you have only a few observations, you can visualize the interrelationship by putting by putting the observation, along, this spider, this radar. Let's say the test score, physics, chemistry, biology of all students. Yeah, you can do that. You can look at whether student can perform better in a particular subject matter, and also whether there is any interrelationship between this subject. Okay, yeah. So the problem is, when you have 100,000 observation, when you have more than 2 or 3 observation, you have a big mess. Yeah, it's really something you don't want to present to your client or to present it in a paper. So when you have a dynamic system, then you can do the local filtering. Okay, I was told that the internet isn't working, so I will not click on the link. But just pretend I click on the link. Okay, rather than showing everything, okay. Here what you see is a Google, is a research project sponsored by Google to look at the future readiness of some countries. Okay. Well, when you present all the countries, in a single spider or radar graph, it will be a big mess, overplotting. Okay. The solution is quite simple if you have a dynamic system. So you can simply use the local filtering. Look at 3 or 4 countries at once. Okay, I want to compare China against Singapore, against Vietnam, and so on. Look at your focal interest, your focal target. Okay. Okay. So also when you have a dynamic system, rather than you show your data at every level, chances are you have hierarchical level. That you have cells. A month, a year, quarter, month. You have the GIS information, country level, state level, city level, and so on. When you want to show everything at once, it will be a big mess. So one way is that, how about do a drill down? Here is, we will see some real the data. Airline delay. Well, when you travel, you want to find out which airline tend to delay. Turn out it's American airline. Okay, but you want to know more information. Then when you have a dynamic system, you can just mouse over. Then you see a pop-up. The pop-up will show you that the worst month is June. Is June or July? Yeah, June. Okay. Okay. So now by intention, so you can drill down. Oh well, the worst is AA, but then the worst month of AA is June. But then also you can mouse over to look at other airlines, Southwest, US Airways, UA, and so on. You see the pop-up to show you more detail. And then you can, on the pop-up, you can drill down further to get the worst. The worst is June 22nd. So I will not fly AA on June 22nd. Okay. The same can apply to GIS information. As I say, you may have hierarchical data structured by country level, state level, county level, and also and so on. But once again, rather than present everything at once, or look at the whole thing at once, you can drill down. Okay. The next thing, okay, the next thing is quite simple. How about linking? when you have multiple features, you want to find out the interrelationship. You can do some very fast profile analysis. Let's say I want to find out the best student. Who are they? What is their profile? Then I just open every relevant features, their background information, demographic, gender, home state, high school GPA, SAT. Then by just one click, as mentioned before, in a dynamic system, all objects are interlinked. So when I click on just one, let's say the best student in terms of their performance at college, then all the corresponding cases will highlight. I know that, okay, the turnout actually the best performing student at college, they may not score well in high school and also SAT. Okay. Okay. So now I want to do some, show the action. Okay, many machine learning model target at prediction, right? Unlike traditional statistics that you want to do a single point estimate, you want different scenario. What if you want a distribution of outcome? So now I want to, let's say I want to do like a veggie assumption, smoking, exercise, also alcohol to predict obesity. And rather than using just one single model, okay. So it should be open in okay, right here. Yeah. Okay, so rather than just a single single answer, okay, I can ask what if question. How about I encourage everybody eat more veggie. How about I tell people don't smoke, reduce smoking. Okay. How about I tell I just hand out free gym membership. Okay, do more exercise, and also I also heavy tax on alcohol to decrease alcohol. So when I do this, when I move around the input, then I can have different scenario of the prediction outcome rather than a single. Okay, our mouse is so hard to do. Okay, so let's say eat all veggie. Okay, let's say no more smoking. Okay, exercise more, no alcohol. Then this is the outcome I can get. Okay, and okay, so however the world isn't quite simple, right? And now what you look at is like 4 or 5 things, 4 or 5 feature predictor concurrently to predict an outcome, obesity. But how about this input? They really have some interaction. Well, okay, in the past, when you want to detect interaction, this is quite confusing. Okay, well, you create a new term and then you run the regression and so on. But now we have technology. Okay, so and this is much easier. Okay, grant access. Okay, hopefully it will work. Okay, Safari. Yeah. Okay. Well, so when you have an interactive system, you just boom. Then you put down an input, and then you use a movie-based visualization to detect whether there exists any interaction. It's quite simple. If by definition, what is interaction? Inconsistency, which means the effect of A on B is inconsistent across different levels of C. When this is consistent, then no change, no movement. The movie should be frozen in every. When I play the movie, then every frame should look the same. But when you see the mesh server dancing around, okay, dancing, then there must be intention. Yeah, just one sentence. When you see movement in a movie, there's intention. How hard is that? Okay. So, okay, here is another example. How about time series? You want to look at like 5 or 6 features together, and like okay, crime rate. Once again, okay. How come it asks me for permission every time? Okay, so here, okay, what you see are real data, U.S. crime rate. Okay, so now let me just go back to 1973. 5 decades ago. Okay, I want to look at like how the crime in the U.S. changed over the year, and there are some conditions like the circle, how big or how small they are, means population, big state, small state, so when I play the movie, okay, 75, 76, hold on, sorry, okay. Let me just stop the movie for a moment. Okay, let me check this in New York. This is, okay, New York and, okay, California. Look at them. Outlier, New York. See? Okay, going back, New York, go back. Yeah, back. Okay, California, New York, going back. Okay. When you slow down and observe the movie, then you can find a lot of insight about U.S. crime. So back then, 5 decades ago, you see a very strong association between sexual assault and also robbery. But after 1990, their connection become weaker and eventually disappear. And also, the U.S. crime rate has been steadily declining since the 1990s. Okay. And also, there are some outlier like New York, but now New York become safer. Okay. So you cannot discover this insight. Well, you can, but it takes more effort. Using a dynamic visualization system, you can play the movie and then you can see, how things change. When you want to see a change, it means temporal. You need animation. You need a dynamic system. Okay, so last but not the least, a good system should be intuitive, which means the silent feature will pop up. So with our condition, okay. So here, you see servo, displays, and once again, it's not frozen. So now, I mentioned that a good system should pop up something. You can't miss it. Here, you see a heat map, right? Oh, right here, San Francisco, between 3 p.m., between 3 and 6 p.m. in the southern region. This is what happened. Okay, you cannot miss it. It just pop up. Okay, I think time's up, right? I will stop here and I will open up. Here's my contact information and any questions. No question? Okay.
Hi, thank you for your speech. I'm doing the analyst intern before, and I really like the product that you showed us. I'm wondering, can we use the product right now, or will you have more available diamonds in the future for us to use?
Oh, okay. You're asking what software I use, right? Yeah. Okay. As mentioned in front, I have. So I use a servo software, and you can do all this, and you can do all these things using StarsWire, Jumpo, and also the Tableau. It's easier, okay, I show you web pages. It's easier for you to convert the visualization result into web pages by Stars or by the StarsWire or the Jumpo. Okay, Tableau, you need more effort. Okay. Okay, no more question, right? Can go now.
Thank you, Alex, for sharing. For showing us the dynamic data visualization system. Really great dashboards and demonstrations.